outside with the original ballistic part. And here what we see on screen is the composite being slowly and very carefully being hosted and then will be mated on top of the rest of the launcher.
Voltando, galera, com a transmissão aí, deu um errinho aqui.
Looks like it's been raining there. It was raining when...
Probably even snowing.
Maybe snowing.
It's still winter is not over there, and what we see now is that the tower and the gantry is being closed for final mating and preparation.
So we are 2 minutes and 30 seconds to launch Rocket on the pad in Plesetsk in northern Russia. We have various events that we need to look out for. Nick, there is a 14-second
vai soltar o foguete que é para
before liftoff.
O lançamento de um foguete que é um satélite que vai estar lá em cima, vai ficar pastorando a temperatura da Terra, como é que estão as tábuas da maré, como é que está a radiação solar que está no planeta, o clima que está aqui nas alturas, como é que pode dizer, chuva, assim, esse negócio também, vulcão, esse negócio de longe, entendeu? Eles vão ver, é como se fosse um satélite que fosse detectar tudo que está acontecendo aqui no planeta, de lá de cima mesmo, entendeu? Vai, assim, dar mais um futuro melhor pra gente. Ele vai ajudar melhor a gente a saber qual é a temperatura real da Terra e qual vai ser a previsão de tempo de hoje, né? Então, vamos assistir completo aí. Melhor vocês vão ver aí quantos minutos falta pra temperatura. Quantos minutos falta pra começar.
Teams have done this many times before. Coming up now to 1 minute to launch. We are going to go silent, switch off our microphones, and watch the launch.
Voltando aqui para vocês verem. Olha aí os minutos. Pra vocês saberem, 17 minutos, 52. 17 horas. Eita, tá errado. É a hora de lá, perdão, meu.
Many times before. Coming up now to 1 minute to launch. We are going to go silent, switch off our microphones, and watch the launch. What happens between 0 and 4? It's basically all systems and then the lift-off before launch.
Tá vendo que a linguagem que eles estão falando é russo? Olha aí, galera, lançou. Nossa, olha aí. Até agora, você nem fala no sistema sumiu.
And there we go. We are... Philippe, what's happening to your satellite right now?
Well, it's starting its journey. I can tell you it's always a little bit of an emotional moment. I think that launching a satellite in orbit is similar to launching a ship at sea. You know, you've worked for it, you've waited for this moment, and here it comes. Very beautiful pictures that we've been able to witness, I have to say, with a clear sky and voila. We also get, I mean, I think that everybody's been able to see the strength that there is in this launcher. You know, our satellite, once it's in orbit, is in a very smooth environment for what concerns at least the mechanical environment, because it's just floating in the air once up there. But now, for this launcher, you can see with this big boost and all the vibration that goes to it, it's a very bumpy ride, really. It's
It is in the first phase of the flight, isn't it? But right now we have separation of the first stage. We're now burning the second stage, Nick.
Yep, this burns for about 3 minutes and it takes us right over the North Pole, and at the moment we need to accelerate. So we've gained a little bit of altitude, but we need to go fast enough so that when we stop burning we can actually stay in orbit.
And if you look at the front of the launch vehicle, you can see here what we call the fairing. Nick was referring to that earlier. It's the pointy
section. Vou pausar aqui para tentar ver aqui direito. Entendo um pouquinho de russo, então vamos ver. Olha aqui. A magnitude dele tá 10.48, que ele tá a menos 0.18 graus. É a altitude que o foguete está. E aqui tem uns outros dados, tem dizendo aqui as informações tudinha, quantos minutos já tá, mission time, são já 1 minuto e 57, altitude 10.109.6. E aqui tá a trajetória dele, a final da trajetória dele tá aqui, Landmark Visibility Zone, deixa eu ver se eu consigo traduzir.
And if you look at the front of the launch vehicle, you can see here what we call the fairing. Nick was referring to that earlier. It's the pointy up.
Olha aí.
The lift-off time was 1757.51.
Now this is the scheduled moment now for the upper stage to switch off and switch on of the breeze upper stage. So we've lost the second stage, we've switched on the breeze upper stage. We're starting the next part of the journey. Breeze is taking the wheel, Philippe. It's going to take, what, about another hour and 15 minutes from now. What's Breeze's job?
Breeze has the important task to bring our satellite exactly on the precise orbit where it should be. In our case tonight, we want to be at the same altitude as an Sentinel 3A, just a little bit above for the commissioning phase, 10 kilometers above actually. So the satellite has its own engine and can change its orbit, but this costs fuel, and so it's very important that we have a precise orbit right from the beginning, and that's where it's critical to have a performant and let's say on target third stage like Breeze will very likely due tonight.
Galera, deixa o like de vocês
It's a little bit like a sophisticated taxi driver. It takes its passengers where they need to go. Nick, it's a fascinating piece of kit, isn't it? Because it's effectively a spacecraft in its own right.
Absolutely, yes. It has to be very autonomous, so it has to really think for itself and be able to decide when to do exactly what it has to do. It has its own onboard computer with guidance, navigation, control. It has its own tracking and telemetry system, so it can talk to the ground and tell the Russian experts what it's doing and when it's doing it. It actually has the capability to restart its engine multiple times and perform different maneuvers so that it can take its passengers to different orbits or even multiple satellites at different orbits. So it offers tremendous flexibility, but as you say, it has to be very clever, and it's a spacecraft in its own right.
The Sentinel-3 satellites are a key component in the Sentinel constellation, which of course as a whole provides vital services to the Copernicus program. We're going to take a look now at the kind of services that the Sentinels provide.
With more than half its satellites now launched, the Sentinel constellation is providing a wealth of data on land use, the marine environment, the atmosphere, security, emergencies and climate change. By combining Sentinel satellite data with Earth observations, scientists can develop a clear understanding of many of the vital issues affecting our planet. Sentinel-3, for example, sends back data every day to help scientific projects around the world studying the oceans and the marine environment. Many of these projects, such as EuroHab, which investigates harmful algal blooms, or HABs, can only go out to sea at certain intervals. In EuroHab's case, once every 2 weeks. Sentinel-3 captures a broad view of the production of phytoplankton. The scientists of EuroHab can then take further measurements to break which species the satellite observed, and crucially, which are toxic. At Plymouth Marine Laboratory, an ingenious device called a smart fin is attached to a surfboard to measure the temperature of coastal water, and the motion of water is measured using a smartphone. Back in the lab, these measurements verify and sharpen an interpretation of the data provided by the instruments on board Sentinel-3.
The temperature of the ocean is a fundamental component of the environment. It controls the physical environment through changes in density together with salinity, which impacts coastal currents. It also controls the biological environment, so the growth and reproduction rates of pretty much all marine organisms are temperature dependent.
While a scientific study can only examine a small part of the ocean, satellites can cover the entire planet. By combining Sentinel-3's data with measurements taken at sea, patterns are detected and applications are tested. At Plymouth Marine Laboratory, scientists are also checking in situ data to determine whether plastic and rubbish accumulation in the ocean can be detected from space.
We are going to do a horizon scanning exercise with all the technologies that are available from Earth observation, and we're considering mainly, because that's our expertise, optical methods, but then we're also considering other remote sensing methods like SAR, and as well indirect approaches.
The Sentinel constellation of satellites is at the heart of Europe's program, providing real-time information 24 hours a day, 365 days a year on the health of our planet.
Philippe, this is really important stuff, isn't it? These services are hugely important, particularly as the world becomes more and more conscious of the need for sustainability.
Yes, and I think that as we've seen in the movie, it's about satellite, but also we should not forget the importance of all the data that have been gathered directly on Earth, the so-called in-situ data. Also, what we found with Copernicus is that the data is important, of course, but it's mostly what you do with it, which is critical. And that's the reason why the Copernicus program is about satellite, but it has also an in-situ component, and then it has and it's really the three together that are delivering, let's say, the overall value of the program. And let's not forget that whilst there are institutional services that have been put in place by the Commission, there is also many commercial companies that are now establishing themselves and that are providing added value services, services that you can buy, so Copernicus is not only better about environment, but it's also really a commercial and economic affair.
In a couple of minutes' time, the Breeze upper stage will be scheduled to switch its engine back on again for the first of 2 ballistic phases. Nick, what does quite frequently, but what does it actually mean, and why do we need 2 burns for this particular mission?
So a ballistic phase is when there's no additional energy added to the system. So it's like a bullet. When you fire a bullet, it's left to its own devices. You give it an initial kick, but then the rest of the travel is in a ballistic phase. So the reason that we have this ballistic phase is that to do a 2-burn maneuver is the most efficient way of making a circular orbit. If you want to, when you start with an elliptical orbit. An elliptical orbit is like an egg shape. The most efficient way to make the whole orbit round is to fire at the furthest point, or the apogee, but you have to wait until you reach that time. So during this phase, there's no additional energy required, so you're in a cruise phase.
I think I'm right in saying that it's Kepler who identified the elliptical orbit, the motion of the planets?
That's right. Kepler identified the 3 main orbits from which you can determine the motion of the planets around the Sun, and basically any satellite around a planet.
That's quite amazing, really. It was back in 1571 that he was born. He was a mathematician and an astronomer. Apparently, though, I was reading on Wikipedia that he had smallpox as a child, which left him with hands and very poor eyesight. And apparently, he is known as the founder of modern eyeglass, or was one of the important people in discovering eyeglasses. So upper stage, switch its engine on. I'm in about 20 seconds. Switch its engine off. Getting close now to the end of this burn. And there we have the scheduled moment now for Breeze to switch its engine off. So we are now in the ballistic phase. We are cruising without the engine, which we will do for about an hour, and before it switches the engine back on again. We are now going to go over to Plesetsk and talk to Bruno Beretti, who is the Sentinel-3 project manager. He's in charge of Sentinel-3, and also to Patricia Lopez, who is the Sentinel-3B launch campaign manager. She's been leading the teams throughout the campaign. Bruno, let's start with you. I can see Guido there in the background as well. Hi, guys. Bruno, you've been very involved in getting us to the launch today. Now that we've lifted off, what's going through your mind after all that hard work?
Well, at this point I have to say that I had not much time yet to think about the hard work we've done before. We're still in a kind of the middle of a climax, which is lasting quite long, 1.5 hours, because the liftoff is just beginning. But we have been witnessing so far a number of critical movements, and so far everything is nominal. But we are still waiting for the final injection maneuver that will happen only in 1 hour and some minutes from now. And we are not able to witness this. We will only be waiting when our colleague in ISOC will confirm to us the arrival of the signal and the fact that the satellite is healthy and talking to us. And only at that moment, I believe that we will probably realize that we achieve the objective to put also the second satellite in orbit and to complete our constellation to get an operational mission.
And Bruno, just briefly, people often talk about the Sentinel-3s as the workhorses of the Sentinel fleet. Why is that?
Well, Sentinel-3 is a bit different from the other Sentinel which has been flying so far or we are under development. Sentinel-3 is a multi-instrument and multi-mission satellite, cover both optical and microwave mission, and has an important objective to provide global coverage of the whole Earth's surface, land and ocean, into a very short time. In fact, with Sentinel-3, with both Sentinel-3 satellites flying, we will be able to give an optical coverage of the overall Earth in 1 day, which is something never achieved before. Just to understand, the predecessor of Sentinel-3 were doing this in 1 week or 10 days. And this is allows Sentinel-3 to provide a basis for all the other missions of Copernicus.
So a very important mission. Patricia, you are the launch campaign manager, I think I'm right in saying, for Sentinel-3B. So you've been leading the teams throughout the campaign. What were the highlights for the team during the campaign to prepare the satellite?
I think every day has been very important for everybody here. There was a very good team spirit from day one until the very end. I think if I would have to pick a moment, would be the moment of encapsulation and the moment when we signed the fairing. At that moment we knew that despite the delays we had accumulated in the beginning, we managed to catch up, to go through all the critical activities for the satellite. We knew the satellite was fine. We performed the fueling, we performed the mating with the launcher. So all the critical steps were behind and we could make it back to the nominal schedule. And at that moment we had the opportunity to sign the fairing with all the names of the people who contributed. It was our way to give the people who were not with us at that moment something back to them.
Well, thank you very much indeed to all of you, and our best wishes now as we go through the ballistic phase, and to all the teams in Plesetsk. We are going to take a program. We will be coming back to you in just under an hour at 21:05 local time here in Darmstadt. That's, I believe, 20:05 GMT. We'll see you then.
Parou. Vai ficar assim. Eu acho que vai desiniciar essa parte de baixo.